In this video, we are going to talk about patterns in linear functions. Now, first off, we have to talk about what it means to be a linear function. A function is a lot like a vending machine. You have what's called an input and an output. The input is the x, the output is the y. The input is called the independent variable, and the output is called the dependent variable. So it's probably important to memorize or to know this type of stuff. It's like a function machine. You see, you go in, you get an input, you get a unique output. So it's important to make sure you understand those things. So one way to think about it is when you look at the input and the output, see how -5 you input, you get an output of 4. -2 you input, you get an output -2, 3. All right, this is what you would call a function. Okay, this is a function. This one right here um, is this one is not a function. Not a function. You know why it's not a function? Because when I input 4, I get 2, or I can choose to get -2. When I input 1, I can get +1 or -1. That is not true. This, although you would think it is not a function, it is, because I get a unique input for every output. It's okay for the y's to repeat. So like if I drew this out a little bit, if you see this, here's my domain: -1, -2, 1, 2. My range is when I input -1, I get 1. When I input -2, I get 2. When I input +1, I get 1 again and 2. So this, if I graphed it, would look something like, it would look like a U, also known as a parabola. Okay, so be mindful. But the good thing about this is that we're only going to be talking about linear relationships, so stuff that's going to be in a line. So if we look at problem number 1, it says in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So you have this. For me, when I'm looking at this, first off, I have to know what perimeter is. This one has a perimeter of this one has a perimeter of 6, and that's a 6, and that's a 1. So 12, 13, 14. This one has a perimeter of 1 and 1 and 6. So 2, 4, 10, 16. This is 16. This one has a perimeter of, so 1, 2, 3, 3, 6, 12, 18. So this is 18. So I bet you this one right here has a perimeter of 20. All right, so we have that. So if I make a table of values, I guess my table of values I'm going to have in my X column is going to be rectangles, and then my Y column is going to be perimeter. Okay, so one rectangle, perimeter of 14. Two rectangles, perimeter of 16. Three rectangles, perimeter of 18, and four rectangles, perimeter of 20. Okay, so I have that. Now, if I look for the, so as to say, we have the table, all right, an equation and a graph. Well, a graph, I can do this. A graph, I can plot this. I'm going to go 1 and then 2, 4, 6, 8, 10, 12, 14. 2 and then there's 16. And then 3 and then there's 18. So then my line looks something like that. There's my graph. So it's a line. Okay, so I have a line, so to speak, or just the dots are fine too. And if I think about it, all right, if I write this out and if I think of words, I could say like I multiply the number of rectangles in each figure by 2 to get the total length of the top and bottom sides of the combined figure. And then I take that 2 times whatever. And let's see, I really can't put it in words, but I could probably put it in an equation. If I had to say, how do I get my perimeter? If I say y is equal to, what is constantly happening here? Well, one thing I can tell you is if I look at the pattern, I'm adding, so from the first rectangle to the second, all I'm doing is I'm adding 2. So I have 2 right there, and times, huh, I don't know, 2. I guess if I look at this, I could say if I look at the pattern in the table, what do I see? So I could say, oh, I got it. It's 2 times, I guess, my L plus 2 times my width. Isn't that what perimeter is? So, but my length, that's changing. My width is always 6. So now I have it as y equals 2x plus 12. So there it is as the table, the graph, and the equation for this problem. You have a got it. Why don't you pause the video and take a look at the got it. Um, the next problem we have, the next problem we have is using um, representing a linear function here. So the table shows the relationship between the number of photos you can make and the amount of memory in megabytes left on your camera's memory chip. Is the relationship linear function? Describe the relationship using words, an equation, and a graph. So when I'm looking at this, an easy thing to do to see if it's a linear relationship. All right, look here. Are these going up? Where are these going up by? Going from 0 to 1, 1 to 2, and 2 to 3. These guys are increasing by 1, increasing by 1, increasing by 1. That's a uniform increasing, so I'm okay to look at this data. If I take the difference between these guys, and those guys, if I take the difference of 512 to 509, that's a minus 3. 509 to 506 is a minus 3, and then that's a minus 3. That's constant. That is a constant change. So if I look at this, I can say that as I'm going, the amount of memory left on the chip is losing 3 times the number of photos taken. In other words, I can see no photos taken, 512. One photo taken, 509. Two photos taken, there's 506. 3, 503. How am I getting these numbers? How am I getting the 512, 509, 506, 503? I, I guess I know one thing for certain. I'm taking 512 and I'm subtracting something. So if I look 512 and I take one picture, I'm taking away 3. If I take 2 pictures, I'm taking away 6. If I take 3 pictures, I'm taking away 9. So if I go 512 minus, and I guess I can go 3 times the number of pictures I take, and that's equal to y. Now, when you look at the graph, you could sketch a graph. 0, 512 could be right here. And then one picture in 509 could be here. 2 picture right there, right? 3 picture right there. 4 picture. So it's a constant decrease situation. So you want to be very mindful of that. You have a guide. Why don't you take some time and pause the video and do it. So dependent variable, that's the one on the y. That's the output value. Independent variable, that's the x. That's the domain. Linear function means when you graph them, they look like a line. So I know this one took a little longer than usual, but it is very important. So hopefully this makes sense. Be sure to rate yourself, and I look forward to seeing you in class. And may the force be with you.